Okay. Um, so can everybody see my screen that says BASYN? Okay, great. So basically, I'm going to kind of go into what BASYN is and some ideas we have around an app, and then show you some flows geographically, and then a few models we're using to kind of make sure that this thinking is translocated, so other communities can use it. So the reason why it's called BASYN is because most of the flows on this is about water recapture and reuse. We're using food as the main kind of traveler of that water, though. There's two views, model view and geographic. We'll go into that later. We're going to stick in the geographic view for now. This is a just circular bioeconomy. So the just part is if we're going to relocalize our commons and think about hyperlocal communities, we need to think about justice. And so I'll go a little bit into that. The circular part, you'll see a little bit more about circularity, but this is a common framework. It's basically how nature works or how permaculture wants to, is trying to work. But circularity is kind of a systems-based thinking. So I'll go a little bit into that. And then bioeconomy, we're talking about food, energy, and water here, all based on their own food. And I'll show you what that means. But the model's basic goal is to design out food waste and build community economic resilience around water, food, and energy. So before I dive too far into the map, I'm going to talk about a little bit about the mock-up that we made. This is literally just a template we found and just change some of the numbers. But the user on this is going to be the food waster, which you'll see they're called Island Spring Organics. And right now, the word we're using for food waste is lasts, and that'll make sense more later. But basically, it's the last kind of food waste before. So like you have food for humans, food for animals, and then food for industrial uses. That's the last part. There is a negative balance here. I'm kind of trying to think in a mutual credit concept. And so hopefully there's also the ability to stay in dollars, but potentially also a way to convert into Holo. And the goal is to monitor the system. So quickly go into what, so this is Island Spring Organics screen. They are an organic tofu factory on BASYN Island. They have a lot of waste basically because of the tofu process, but it's really high in nitrogen. So farms really love it, but it's really smelly and really hard to deal with. They also have to send a ton of this to compost, and it's really expensive to get rid of this stuff. So King County actually helped install this machine and a few others, obviously, and Impact BioEnergy and HApp on the call helped install this system. And so I'm going to play the video. It's about 2 minutes, and you'll get a bigger idea of what it is. Oh, wait, can everybody hear that, by the way? No, okay. I might have to.
Just take your unplug your headphones from the computer.
Yeah, that's what I'll do. Okay, let's see if this works.
Introducing the Impact BioEnergy Nautilus Series Modular Anaerobic Digestion System. This bioenergy system represents a breakthrough in scale, simplicity, and affordability for on-property food waste conversion to commercially valuable products. This truly is a zero-waste system that does not rely on a sewer connection or residual waste trucking. It is scaled to small to medium-sized communities, including campuses, islands, farms, and resorts. This system can accept up to 29 tons of urban food waste per week from adjoining food manufacturing facilities and restaurants, groceries, and craft beverage manufacturers. With just a 30-day residence time from receipt of food waste to valuable end products. The system is first in the industry to generate raw biogas energy products at an on-property scale, including propane substitute and CNG. Future mobile electric vehicle charging is planned in phase 2. Liquid probiotic plant food is also generated, and future year-round plant food drying is planned for the upper greenhouse area in phase 2. With the Nautilus, we're inspiring and enabling people to find a better way to move water, carbon, microbes, and organic matter back to the soil. The entire system is relocatable and requires almost no site civil work. Zero waste, clean energy, and growing healthy food and economies are universal aspirations. The Nautilus can make these aspirations reality.
Okay. So I'll show how the machine sends water. So they're getting collected in these totes and they're on this trailer. And then the trailer is gassed by this, it's basically the digester works like a cow's stomach. It's actually used with a starter. And it basically causes the thing to fart, and the farts get caught in this. It's basically just methane, but it's being captured. And then it gets converted with this machine to make it so a truck can use it. And so instead of the Island Spring Organics sending the compost, which is really wet, heavy food waste, away to another centralized compost facility, it's using it on site. And then it gets sent to this truck. The truck gets gassed up. We're still in the middle of converting this because of COVID, so it's on pause. But the goal is to use the truck to drag that trailer, and then the trailer gets brought to this farm, which is just on the other side, which is experiencing climate change water issues. So they installed a 5,000 gallon tank to then use the fertilizer, bio-fertilizer on the plants. And so they're doing tests right now on the farm. It is all organic waste as well. So it's organic food systems or biofertilizer. So this is the main flow we're trying to understand and how to use Holochain for. Each system, like Matsudo Farm, has a water-based liquid inputs that they're buying. On the stance of the digester, they have multiple outputs. They have the liquid biofertilizer, they have biogas, they also have transport costs. So they're actually charging people for this stuff. And so they have a positive balance here. And then Island Spring Organics pays to get the food waste taken away. And so they pay to get their lasts exported. Hopefully they get exchanged for, goods like, heating for some of their systems, or gas for their stoves, or discounts for the county to help them pay for keeping this waste on site. And Shroop can go into that stuff later, but I'll just go into kind of how this model expands a little more as well. But right now, just so you understand, this is using systems. The reason why we're using Kumu is because if you make a change in water systems, you also affect food systems. If you make a change in food systems, you also affect energy systems. So we're looking at systems thinking as a way to connect all these together in a more holistic understanding. But we're also making sure we're thinking about people in this as well. And so that's why the justice element. So as I think about expanding this view, I'll just show you kind of how it works. So here's the decentralized AD. You saw it made biogas, and this is the liquid plant food. It goes to the Matsudo farms. And then the goal is to get that food to go to a school or something where they can buy the food, and then the waste of that food gets sent back to the digester. And so then you would have a completely regenerative closed loop system. Right now, this phase of the project is not for this phase. The current phase is just this phase right here. And the other thing, right now, all of this food waste gets extracted and taken off island to get composted. And also it goes to the dump. A large percentage of our dump is also food waste, and we're trying to lower that, obviously. But I'll show you kind of how this whole thing gets extracted. So now the goal is to keep it on site, but what's happening right now is most of it's getting exported off of this island and sent to Cedar Grove Compost. And this is a private company right now. And King County actually subsidizes this entire flow. So instead of subsidizing the extraction of this resources, they're helping them keep the resources on site. So that's why we're calling it regenerative. We'll talk about expansion later, but once you start expanding and closing loops, you have to think about other stakeholders. And Just When Organics is going to be part of this conversation as well, but we'll get into that later. So here's the circular economy framework we're using. Principle 1 is transition to renewables. Principle 2 is circulate materials. Principle 3 is design out waste. We are specifically talking about the anaerobic digestion and the biogas part of this, and obviously biosphere restoration, because we're replenishing water as well. And this system is being used across the world, from Google to Amsterdam and this is Amsterdam's work. You can also see more about Amsterdam's work on this little link here if you click on it. But the basic idea is that we're thinking about translocalism. So we're using structures that other cities are using. So Amsterdam uses this language. So do multiple cities across the world. So that's why we're using circular economy as a basic framework. And then the last thing I'll talk about is the commons part. So this is a framework we're using called Just Transition, which is what America uses actually for more justice-based thinking. But the basic idea is that we have an extractive system that's like, kept in place by like militarism and enclosure of wealth. And the goal is to transition to one that's regenerative and that has deep democracy and, regeneration of resources. But the important piece here is that we're talking about a values filter that shifts economic control to communities and democratizes wealth in the workplace. So a lot of our thinking in this model is to consistently come back to an ownership structure that's like that. So Impact BioEnergy is actually looking to make this system community owned. And so that's kind of what this goal is to think about, technology through Holo, but also think about how does the community stay in touch with the ownership of this system as well. And Shroop can talk about more of that. But I wanted to kind of leave it there for now. Oh, I did want to also show the expansion of how this fits into Seattle. So these other purple dots are other digesters that Impact BioEnergy has. The main kind of technology that they've done here is to decentralize biogas systems or deep digesters. Most of them are gigantic systems that are centralized, like compost, but they're decentralizing ones. So here's one at our food bank that's going to go at the bottom of the food bank, charge some of their building, and also water their rooftop farm. And then those water, that bio-fertilizer, the liquid bio-fertilizer will also water the local farms in the area around the community, but also the UW farm that we have, the University of Washington farm. So it shows kind of why water should stay on location rather than getting exported to just get centralized compost or the garbage, obviously. But this shows how we're hoping to multiply this model. But we're going to stick to the pilot for now. And that's pretty much what I have. And yeah, so the last thing would be data, and that's where Shroop would get in. We're trying to make sure we're being really clear on why data, whose data. Obviously, Holochain has that value set as well. So right now you can access the data if you click on this, and you can see more of some of the flows here that you can see here. So that's what I have. Shroop, do you want to add anything that I missed?
No, I think that was an awesome overview of everything, basically. It's amazing to see this all kind of mapped out because I've been trying to tell this story for quite a while and we haven't had, this type of illustration of it. So yeah, awesome, Komal. This is like basically covered everything. It comes down to decentralizing, proven technology. I think one of the problems we're trying to solve here, of course, 30 to 40% of all of our food goes to waste, but then where are those concentrated generators and why are we hauling it around? It turns out, 90 to 98% of that material is water. So they're basically hauling water all around the county. into different communities, it's extremely diesel intensive. So our entire premise was based on minimizing the trucking. And so there's an entire embedded carbon value here that we're trying to also put some metrics to. And it turns out that roughly every ton of material can be utilized on site to mitigate about 1 ton of carbon equivalent emissions, carbon dioxide equivalent. So if you look at this project on a yearly basis, maybe 1,500 tons per year is what we look at converting. So that's roughly 1,500 tons of mitigated carbon equivalent. So in the end, water is a common denominator, but also carbon is a common denominator. But until we start mapping this out and putting numbers to it, there isn't much to talk about really. So I feel like we're finally at this point where we can start putting metrics to it. So right now, the numbers you see on the left, about 1050 gallon equivalents, those gasoline gallon equivalent, GGE is the acronym, per month. And that's on the lower end. So right now we have about 16.5 gallons on hand in the filling station. Now that's really conservative. We hope to produce up to 5 times that per month. So maybe about 5,000 gallons per month based on the inputs. And what we're finding out is that Island Spring, those inputs, they're really high in nitrogen, but they're not as high on the energy side of the equation. So this is kind of like a balancing act where we want to optimize the nutrients in the bio-fertilizer, but also avoid diesel and then substitute for diesel. So this truck that we're using, hopefully we can convert that truck over the next couple months before summertime, and then actually start filling and showing that added carbon mitigation from that activity. On the biofertilizer side, it's kind of like that is more than 90% of the value, because every ton going into the system, about 92 to 95% of that ton comes out in the form of biofertilizer. So on a monthly basis, we're looking at about 116 tons per month of the material. Right now, we have about 33 on hand. And what's really interesting is that 33 tons of biofertilizer on hand the timing is amazing, because now we have spring, of course, and the farmers are looking to actually overproduce and support, food banks more and people who need the food. So we have this really amazing opportunity in front of us where we can now add value to the farmers, provide them with supplies that they might not have had before, and they don't necessarily have to pay for it. So we have some grants through the land trust. So Vashon Land Trust, they're the ones who own Matsuda Farm there. So they're a key partner because they're pivoting to basically farmland restoration. So in the end, Matsuda Farm is the first to have the tank there. So that tank is full, and now we're entering into the season where they're going to need a lot more of the liquid. So I think over the next couple of months, we should be able to get a lot more farmers involved and subsidize that earth shot, if you will, to their farm, because they really need it now. It's like all the farmers, their markets have collapsed, but they still want to come to the rescue in the situation and overproduce food for people who need it, and maybe we can help. There's another aspect to this project.
Before I move on to, obviously we want to design this currency with you guys. We want to design the app with all of you. And I think Bear is going to help kind of get us in front of some of the hackathons that Holo is doing. We're trying to keep things more open. We're looking at Holo REA as a way to integrate potentially, but we're just looking at different models, trying to understand the Holo system right now. And so before we move on to talk about kind of how this might expand and even maybe how Just One Organics fits in, who knows? But before we do that, any questions before we move on or thoughts?
Do you mind sharing a little bit the background of the project and how it got started?
Sure. So this project started in 2014. I was doing my business school. It was an MBA in sustainable business. So I went to Bainbridge Graduate Institute. And at the time, we were looking at a project for BASYN with their organics. So the problem is BASYN Island doesn't get that third bin that we get around Seattle, which is basically the third bin for food and yard waste. So King County had sponsored a feasibility study to say, okay, here's Vashon Island. Can we have a community scale digester on the island? What could that look like? And so King County, they've been really pushing the needle on diverting. Their goal is 100% diversion of food waste by 2030. Meanwhile, the state of Washington just came out with a mandate to reduce 50% of food waste by 2030. So because King County's goals are much more aggressive, the entire state is kind of piggybacking on King County, and King County is kind of piggybacking on Vashon because they're the ideal situation to start demonstrating this. And so we had a small grant from the county. We grew that into a grant from the state of Washington Clean Energy Fund. And so we had roughly a $500,000 grant. We had matched that $500,000 with another $500,000 from the Sustainable Energy Trust. So we basically have a mortgage on the system now that we at Impact own, and we're looking to now democratize that entire thing to say, why doesn't the community now, not only spiritually own the system, but fiduciarily? Why aren't they seeing the profits coming out and the farmers see the profits coming out of it? So now it's really about taking the next step to demonstrate how we can co-op it and then democratize it and actually offer the system as an asset for anyone to invest in.
Yeah, and then I'll just add, so how Shroop and I met, we went to grad school together, and I was doing something called Uber Local, which was basically I was doing group buying of local food and helped create a food hub and experimenting on peer-to-peer hyper-local food systems. And I was also trying to look at cooperative business models in that as well. And so we met and actually started geeking out on this idea of something called mother trees, kind of both of us thinking about nature and how would nature solve things. And we realized our concepts work together. I was on the fresh food side, he was on the waste side. And so mother trees are basically large trees in the forest that feed smaller trees in the area through mycelium. So we just kept going with that mental model or that metaphor, and just been designing on that for the last like 3 or 4 years. And I got away from fresh food. So I no longer focus on fresh food right now. I've been mostly focusing on the circular side, which is like the inputs or outputs of the farm or food system.